Hi, how are you? This is, let me shut the door, hold on. This is example 7. Example 7. From problem set 10. Let me read it to you. You should get out your problem set 10 and read it yourself. But what I'll do is I'll read it. It says Palmer drops an ice cube into his glass of water. The ice, whose density is 917 kilograms per cubic meter, has the dimensions of 0.3, 0.2 times 0.2, as shown in the diagram. What is the buoyant force acting on the ice? A little confusing. So this is the ice. This is 0.02, that dimension, 0.02, that dimension, 0.03, that dimension. I kind of exaggerated the length a little bit. I just wanted to make the drawing look a little bit bigger. So these are the dimensions: length times width times height, okay? 0.03, 0.02, 0.02. And what else do we have here? We have the density of ice is 917 kilograms per cubic meter. That's what the density is. We have here that the buoyant force will equal the weight of the volume displaced. The weight of the volume displaced, which will also equal the weight of the ice. It's floating, okay? It's floating. All right. We know this equation here, FB, the buoyant force, will equal the density of the ice. We don't know how much water is going to be displaced, but we know the dimensions of the ice, so we're going to use that. Bear with me. We're going to use the density of the ice and the volume of the ice, okay? Why can I do that? Well, let's do a dimensional analysis. This is actually dimensional analysis, not what they say in other courses you may have had. Well, density is mass over volume, G, and then V. The V's cancel. I'm left with mg, which is the weight. So that weight of the ice will equal the buoyant force of the ice. Therefore, the buoyant force equals the weight of the volume of fluid displaced, which equals the weight of the ice. Okay? Now, when you multiply length times width times height, the volume of the ice, I already did this, it's actually in the example, is going to be 1.2 times 10 to the negative fifth cubic meters. 1.2 times 10 to the negative fifth cubic meters. Okay? 1.2 times 10 to the fifth cubic meters. Now, we know that this is true, correct? I can erase that. Okay? We know that that's true. Therefore, we're going to plug in to the equation. FB equals the density of the ice, G, the volume of the ice. Okay? So that's going to be 9. I'll leave off the unit labels because I know all the unit labels are fine. I'm using density, kilogram per cubic meter. I'm using volume, cubic meter. I'm using G, which is meters per second squared. So everything is good. Okay? So that's going to be 917 times 10 times 1.2 times 10 to the negative fifth. 1.2 times 10 to the negative fifth. And that's going to be equal to 0.11. Okay? 0.11. Now that's the weights of, you got that? This is 0.11 newtons, yes? I can erase that now, okay? 0.11 newtons. Therefore, I have the weight of this, 0.11 newtons, which equals the weight, positive, right? And then I have the buoyant force, which equals negative 0.11 newtons, okay? So the buoyant force is going to be going up. I know that's the weight, I know it's equal to the buoyant force, so we're all done, okay? That was example 7. It will be on the test. That will be example 7, problem set 10. Have a good one.